Welcome back. We're on problem number 28. One of the most fundamental skills you'll need this for the next several lessons. Determining the number of valence electrons that are in each of these atoms of these elements. And is very related to what group it is on the periodic table. Up first, we got nitrogen makes up 78% of our atmosphere. So you are breathing that in right now if you are alive. So nitrogen is over here and is in group 15, so the last digit of the group number will tell you the number of valence electrons. The Lewis dots might look something like this: 1, 2, 3, 4, 5. All right, up next we have lithium and the alkali metal. That is group 1. Those are very reactive. Why? Why are they so reactive? They have one lonely electron, right? Group 1. One lonely electron. They would love to get rid of that to become a stable ion. There's your Lewis dot for that one. Next we got phosphorus, cool cousin of nitrogen. Why do we call them cousins? Because some textbooks call these groups families. Right, phosphorus. What do you think? Right there, group 15. Did you say 5? It's got 5 valence electrons. Barium, alkaline earth metal. All those elements down group 2 have 2 valence electrons. Barium's way down there. Barium. 1, 2, there's your Lewis dot for that. Bromine, off to the halogens. What have I not used? Let's go with also very reactive, because it only has one more electron it wants, those halogens, to get the octet, to achieve the octet. Bromine, group 17. Did you say 17 valence electrons? Nope. 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So it got one spot there. It would love to get one, maybe from lithium. All right, so we got carbon. Why is carbon so versatile? It makes up backbones of all our organic molecules. Because it has 4 valence electrons, it is makes it a very versatile. There we go. How about green? 4 valence electrons right there in group 14. It's backbone of the chemistry of life. All those organic molecules we learned if you took bio, your proteins, your nucleic acids, your carbohydrates, your lipids, building blocks of life. All right, let me show you how. Let me just quickly tie this in to what we learned in our last chapter, the periodic table. This is your S block. This is your P block. So these elements are main group elements. And so the valence electrons for those main group elements are the electrons in the highest S and P. So for example, for barium right there, it's in the 6th period. So you just count 1, 2, 3, 4, 5, 6. So it's final 2 electrons. Because it's in the 2nd column of the S block, it's going to have the electron configuration of all that stuff before it, but the final electron configuration is 6s2. All right, and over here, bromine also, this is the P block. All right, and since it's in the 1, 2, 3, 4, 5, there's 6 spots for each, representing each of the electrons that fit into the P orbitals. Since it's in the 5th column there, that electron configuration is going, all those elements are going to end in NP5, where the N is the principal quantum number. Right, so that for bromine's case is going to end in 4p5. So that's how we know quickly how many valence electrons all of these elements have, just by looking at the periodic table, especially if they're main group elements where they're in the S or the P block. Right, so that, just check it out. Barium's got 2, phosphorus, or oh, hold on, I just barium, bromine does not have 5. I'm sorry, let me take that back, because barium also has these 2 in S. So let me back up a little bit. So for bromine, it has 4s2, and then 4p5, making it 7. Okay, sorry about that. So all the halogens have a common electron configuration of ns2 and p5. So let me slow down a little bit. So there's your 7 valence electrons for the halogens, coming from 2 coming from the s's, and then 5 coming from the p's. All right, there are 7. Make that clear. 7 valence electrons.